Hey everyone, so today we are going to talk about motion in a plane, which is chapter number 3 of NCERT. So let us start this chapter. So first we will talk about this topic, basically the chapter starting point. What is motion in a plane, right? So motion in a plane is just like we studied in earlier chapter, which was motion in a straight line. So in motion in a straight line, the motion was in one dimension, and in motion in plane, the plane is defined by normally 2D or 2 dimension or 3 dimensions, right? So plane is basically defined in 2 dimensions, and space is defined in 3 dimensions, right? So motion in a plane is a 2-dimensional motion, right? So motion in a plane means 2-dimensional motion, right? This is a simple example. 2-dimensional motion, like in x and y plane, like in x direction also. So x is there, y is there. So motion is in xy plane, right? So it's a simple example of what is. Now to understand it in more clear way, right? So this is a 2-dimensional motion example. We will try to understand it in more detail. So let us go to now to study this motion in motion in 2 dimensions, where we will try to calculate the displacement, position vectors, and displacement vector, and then velocity and acceleration vectors. So we will first start with how we can measure the position. So to measure, the important thing is that to measure the position of an object in 2 dimensions, you need a quantity called vector. So vectors are required, right, for defining position and displacement velocity etc. in 2 dimensions or basically in plane, right? So this vector is something which is significant. Now, so let us talk about the vectors. You may have studied about vectors in class 10th also, right? So let us talk about these vectors. So what are these vectors? So if you know, before starting with the vectors, we will classify the quantities based on their magnitude and direction, right? So quantities, basically physical quantities, are classified in 2 categories, right? Right? And what are the 2 categories? One is they are scalars. Second is they are vectors. So this is what we usually say, but this is not exactly the case. Let me tell you that all physical quantities, in the natures are tensors, right? So this is something you need to remember, tensors. So tensors of order 0 are called as 0 called scalars, and order 1 are vectors. So quantities are not physical quantities are not classified into categories, but there are higher categories also. So general category is tensor, and the particular categories are scalars and vectors. So order 0 tensor is scalar, order 1 is vector, right? Now let us talk about some of the properties of the vectors and scalars, right? Scalars, right? So let us talk about the scalars. Scalars are quantities, physical quantities having magnitude only, right? वो फिजिकल क्वांटिटी जिनके पास सिर्फ और सिर्फ मैग्नीट्यूड होता है उन्हें हम स्केलर बोलते हैं, are called scalars, right? Now the important thing to understand here is, अगर हम इसको सोचने की समझने की कोशिश करें क्यों ऐसा होता है कि स्केलर के पास केवल मैग्नीट्यूड ही होता है. The reason is, as I already said, कि all जितने भी क्वांटिटीज हैं इनवर्स में फिजिकल क्वांटिटीज सारी जो है टेंसर्स हैं, और टेंसर जो है जीरो रैंक टेंसर जो होता है उसको स्केलर बोलते हैं, और रैंक 1 टेंसर को वेक्टर बोलते हैं. ठीक, तो रैंक 0 जो टेंसर है, अगर उसको हम 3 डायमेंशन में इन 3 डायमेंशन, what is the in 3 dimension? Now the tensor has a property, order of a tensor. So tensors have this formula. So if order of a tensor is p, then a number of component it has, tensors component. Right? Tensor components are n to the power p, right? Where n is the dimension it has, and p is basically order of tensor, right? So, basically rank of the tensor let me write it, rank of the tensor. Right? Rank. So rank of the tensor is there. So in 3 dimension or any dimension if you choose, so as scalar is the order 0 tensor, it has n to the power 0, which is 1. So scalar has only one component in all dimensions. Right? It means that it doesn't change it in whether you take in 1 dimension, 2 dimension, 3 dimension, 4 dimension, or any dimension. Scalars are always constant quantities, right? So these are called tensor of, and that is why they are there. Now, so here scalar has only one dimension. Now let us take the simple example. After a scalar, so what are scalars? Mass is considered as a scalar, right? Then time is a scalar, right? These are some of the scalar quantities. Temperature is also a scalar. Right? So these are some of the scalar quantities. Now one thing we need to remember that there are some of the quantities which look like scalars but not scalars, right? Like pressure is there, moment of inertia is there, current is there, and then you have strain is also there. So these are some of the examples. So these quantities are not scalars, remember that. they are tensors of a rank greater than 1. They are not neither vectors also. So tensors of rank greater than 1. Right? Which means that rank 1 is vector. It means that they are tensors of higher rank. They are not neither scalars nor vectors. They have more number of components than vector in a given dimension. In 3 dimension, 2 dimension, or like that. So remember that if it is asked in a question exam, you always remember these things. Any physical system, physical quantity which depends on the material's intrinsic property is a tensor. Right? So these are some of the examples. Now let us go to another quantity, another physical quantity which is called vector. Right? So what is vector? No, let me somehow describe the algebraic properties of scalars. So what are the algebraic properties of scalars? Now scalars can be added, subtracted, multiplied or divided, just like any mathematical quantity. Mathematical number, right? So you can take like time is like 1 hour, right? So it's 1 is its magnitude and hour is its unit. So scalars can have unit, remember that. Magnitude with unit. Now it can be divided, it can be written in 60 seconds, 60 minutes. So how it multiplied? So 60 minutes is nothing but 1 multiplied by 60. So it can be multiplied, it can be divided, right? If you want to change into a days, so it is 1 divided by 24 days, right? Equivalently, right? 1 multiplied by 60 minutes or 60 minutes, which can be further, it can be added also, right? So it is like the 30 plus 30 minutes. Right? It can be subtracted also. 2 hours minus 1 hours. Right? It is 1 hour. So it is a simple example. So that the magnitude never changes and the scalar remains constant independent of which dimension you discuss it about. Right? In 2D, 3D, 4D, 1D, any dimension, the scalars doesn't change. So these are some of the properties of scalars. We have given example also. Now let us go to the other quantity called vector. A vector are significant in our studies of motion in a plane. So let us talk about vectors. So what are vectors? Right? So vector is nothing but a quantity having magnitude and directions. Vector is a quantity having both magnitude and direction. Right? This is a definition which usually comes from means the basic physics, but actually vectors are tensors of rank 1. Right? So in 3 dimensions they have 3 components. Right? Vectors are tensors of rank 1. 3 dimension. So component of tensor is n to the power p, where n is dimension, p is the rank of tensor. Now rank point tensor, so in 3 dimension has 3 to the power more 3 components. So if you take any vector, examples, displacement, velocity, acceleration, force, etc. Acceleration, force, etc. Now remember that all have a number of components following this law, n to the power p, where p is always 1 for vector, right, or rank 1 tensor, this is vector, and n is the dimension. You take in 2D, you have 2 components, in 3D, you have 3 components, in 1 dimension, you have 1 component, right? So in 3 dimension, if you take x, y, z, fx, fy, fz is the force, right? In 2 dimension, it is fx, y, vx, vy, or x and y, and similarly ax, y. So this is an example, right? So displacement, velocity, acceleration. Now they have this. Now what are the sum of the other properties? They follow triangle's law. Or triangle's law of addition, or there is another law, right, called law of parallelogram, right? Right? Triangle's law of addition or the law of parallelogram, they follow. So basically they follow triangle's law of addition or law of parallelogram. So these are some of the, and now we will talk about some of the important properties of vectors, right? So let us start with, we have given examples. So how we will start with the displacement, and then we will go to the position, and then displacement. Then we will go to the velocity, acceleration, and other things, right? So let us start with the position first. Now let us talk about the position vector. So what is position vector? So let us take some simple graphical representation to understand it. You take it as y and this as x, right? Y and x. So and you have a graph like this, which represents a trajectory of motion of a particle in 2 dimensions. So if O is the initial point, you call the reference point, and you define the position of an object at different points as P at time t, right, and P dash at time t dash, right, and then a line which joins these two, right. Now if you look at carefully, so what is the position, right? So position is nothing but of an object in the motion is defined by a position vector, right? If you understand it, so position of an object by position vector, right? So here R and here r dash are the two vectors, right? So if you look at carefully, now how we define the position vector? So position of the object or the object which is in motion at a time t is what? It is OP, right? Position of object in motion at time t is what? Is nothing but OP, right? OP is at time t, and what is OP? It is nothing but the vector r, right? So it has magnitude mod r and direction, right? So similarly, the position of is position of object in motion at time t dash is how much? So it is OP dash, right? So you see O, you are using a reference point, and from where there you are defining the position, right? Which is nothing but r dash, right? It has magnitude and it has direction. So this is what we call the position vector, right? So position vector simply define the position of an object at a given moment of time in motion, right? Now, so this is simple. Now, but this is significant. Why it is significant? It will help you understand that what is the exact position of an object which is in motion at a given time t, right? Or any given time t dash, right? So it will help you in determining its displacement, velocity, acceleration, force, etc. Right? So now let us go to the other thing, other quantity, which is called displacement. Now, what is displacement? So displacement we discussed in the last chapter also, and we are again going to discuss here. But here it is in 2 dimensions, right? In 1D it was simpler to understand. In 2D we will be taking it by the examples of vectors, right? So displacement is nothing but just change in the position of object with change in time, right? So you take any like object is moving from t to t dash, means p to p dash in a given time interval t to t dash, right? So the change in time leads to the position, change in position of the object. So if you want to find what the displacement it has, then you will simply say that, okay, let us take the initial position, final position and minus initial position. So it is final position of the object in the motion minus initial position of the object in the motion, right? Now what is final and what is initial here? It is the positions between which you want to find the displacement of the object. Final means not the end of the motion. It is final is the point or the maximum point up to which the object has reached, and final and initial is the one from where the object has started. It can be any midpoint also, not necessarily. So you choose any two points. So one at a greater time and is the final, and one at the lesser time or the right is initial one. So here t and t dash are in that reference. So final minus initial. So here r dash minus r is the position vector, right? Which is OP dash minus OP, right? And which is P dash P. This is what we call the displacement. P dash P. Now it is represented by an arrow having a head in the direction of motion, right? Represented by an arrow with a head in the direction of increase of the vector. Direction of increase of displacement vector. Increase of displacement vector. Right? So this is something we need to remember. Now, so P dash minus Pu, P dash minus R dash minus C. This is direction of increase of the weight. Now this is one simple case. Now we will try to understand displacement in more detail. Remember that one important aspect which I already discussed in the last chapter. I'm again writing. The displacement is not the mode of distance, right? Displacement, mode of the displacement is always less than or equals to the distance traveled by the object. We took some simple example in the last chapter also, which you can go and relook at to understand, bring more clarity on this displacement thing. Right? Now we will try to explain it here in more detail. Right? Now let us give. I will be giving you one example to make you understand it in better way. Right? So the example is following. Now one important thing which I want to show, it depends on the displacement only depend on the final initial position, doesn't depend on the path. So it does not depend on the path, as I have already mentioned, depend on the path, but depends on only initial and final position. Depends on initial and final position only. So this is important. So if initial and final positions are given, we just subtract them with respect to the time, right? Position, right? Not do not take the path followed by them. You do not consider. If you are considering the path followed by them, that will give you the scalar called the distance. Distance and displacement are two different things. Do not confuse. Let us take an example to understand it more clearly. We have already taken one example. In 1D, now we are taking over the 2D, right? So X and Y, right? So you have a motion is something like this. Right? It is something like this. You take one position O, P. Here we are taking A, B, C, right? And this is D. And this is called F and E. Right? We are taking like this. Now, we want to calculate here this point is Q. Now we want to calculate displacement between the P and Q, right? So displacement between P and Q is how much? So displacement between P and Q how much it is? take this vector. It is represented by PQ, PQ vector, right? Right? So you see, now Q is here, P is here, and then there is shortest distance between the two. Right? This is what we call this. The displacement is this displacement. And what is distance? Distance can be, depending upon which path you are following, it can be this one or it can be this one. Both can be the distances. Right? So this is what the distance and displacement is. Displacement is the shortest path, usually between the two positions. Right? So this is all we have in displacement. Right? Now we will go to some of the properties of vectors, right? Like equality of vectors. What is the equality of vectors? Now remember that two vectors are equal only when they are equal in both magnitude and direction. Two vectors are equal when both are equal in magnitude and direction. Right? So what is the magnitude? First you need to understand. So magnitude, if A is a vector and B is a vector, right? So mod A must be equal to mod B. And what is the direction? Direction of the vector A, which can be mod A divided by, A divided by mod A. Must be equal to B divided by mod B. Right? This is what we call the unit vector, remember that. So unit vectors in the direction of A must be in the same as the one in the direction of B. This is what we call the equal. So let us take an example to understand it. So this is one vector. Let us take it as P, Q and RS as the vectors. They have same directions, right? And then same magnitude. Now these two vectors are equal if you overlap P with R. If P goes to R, then Q must go to S, then only they are equal, when they overlap. So P and R overlap here, right? P is here, R is here, then Q is here and S is here. They are overlapping. Then they are equal. This may happen that A is pointing in the different direction, and Q is this one is pointing in different direction, having same magnitude. Then if P overlaps with R, then Q must not overlap with S. Q not equals to S. Right? Q not overlapping with S. If P equals to R. Right? So this is what we call equality of vectors. So if two vectors are equal, following things will happen. Now let us one other thing, which is called the multiplication of a vector by a real number. So what is the multiplication of a vector by a real number? Right? So let us take A is a vector, then you define a vector B, which is lambda times A, right? Which is lambda times A. So what does it mean? So lambda, if it is positive, it signifies that A and B are related by a lambda vector, right? So if A is having a magnitude A and if B is there, if it is defined, if lambda is 2, let us take a simple example to understand, then B is 2 times A in magnitude, and obviously they have same direction, right? So mod B will be lambda times 2 times mod B. This is what we have. But what happens when lambda is minus? In that case, you have, let us take another vector C is defined, which is, let us take minus 3 times A. It means that mod C is mod A, but with a negative direction. Direction is changed. So if you change this this quantity, this direction of, or basically sign of this quantity, lambda, which is a scalar, a real number, which is a scalar, right? Then direction also changes, right? So C is in negative direction, it is 3 times A, it has 3 times mod of magnitude A, but mod of magnitude A, mod of A, then, but it has a direction which is opposite to the direction of C, of B, A, right? So this is what you need to understand. So C is minus of 3 times A, or mod of C is nothing but mod of 3 times A. So this is one example. So if you are multiplied by a positive, it will simply not change anything rather than just increase its mod, right? Increase its mod. But if you multiply with a negative real number, right? In real number multiplied by, then it will change the direction also, along with the magnitude. You see, this is what exactly. So this thing you always remember, right? Now we'll come up with some of the more properties of vectors in the next class. So please, if you have any concern regarding these lectures, let us know in the comment section. Also, if you have any specific request related to the lectures, you want to discuss anything, you want to ask any question, please write in the comment section.